So in this lesson, we are going to represent, well, I'm going to underline it, represent additive relationships in different forms. So I'm going to give you an additive relationship and we're going to represent it in different ways. So situation 1, Miracle is always 1 year older than her imaginary friend. We are talking about when we hear something like that, where I want you to think about like what two things or what things can change. So Miracle's always 1 year older than her friend. Well, we're really talking about Miracle's age. We're really talking about her age for Miracle and the age of her friend. The topic really is Miracle's age, because we're talking about Miracle, right? Miracle's always 1 year older than her imaginary friend. So we're talking about her age. So we will say M is Miracle's age. Miracle's age. We put the one, I just want you to practice this. We put the one we're talking about Miracle, into variable 2. We're going to take the one we're talking about, which is Miracle's age. We're going to put it in variable 2. So the important subject, or the subject of what we're talking about, will always go to 2. And I'll explain why later. Not this lesson, but in another lesson. And we were also talking about her imaginary friend's age. So I'm going to put I for imaginary friend's age. So imaginary friend's age and Miracle's age. Let's make a table. So 0, 1, 2, 3. You can just number them like that, 4 if you want. Miracle's age. So Miracle's always 1 year older. So if her imaginary friend is 0 years old, Miracle will be about 1 year old. If her imaginary friend is 1 years old, then Miracle should be about 2 years old. If her friend is 2, then Miracle should be 3. If her friend's 3, then Miracle should be about 4. And if imaginary friend's at 4, then Miracle should be around 5. We're always adding one more to her friend's age to get to Miracle's age. So remember, I guess I can try to do this. Miracle is the subject. So Miracle is the subject. Miracle's the subject, so we care about Miracle's age, variable 2. And then we will put that right here, Miracle's age. I'll just put MA. And then the other one we can just leave as normal down here. So, we'll just leave in this remaining spot. This is her imaginary friend's age. I do want you to label those, like start showing me what you're counting by. So 0, 1, 2, 3, and then 0, 1, 2, 3. So when her friend is 0 years old, Miracle is 1 years old. When her friend is 1 year old, Miracle is 2. When her friend is 1, Miracle is 2. When when imaginary friend is 2, Miracle is 3. When her friend is 4, Miracle is 5. I'm going to go all the way. I skipped the 3. So 3 and 4. Friend is 3, Miracle. And it keeps going like this. If you notice, it's like there's a dot each. So if you notice the pattern, you can just keep showing some more. Now, of course, there's like days and months and stuff. So draw that arrow. Now, instead of using a table, we could also use ordered pairs. we would write the friend's age first and then Miracle's age. For example, her friend would be 4 and Miracle would be 5 years old. We could also represent this relationship using an equation. So if we take the imaginary friend's age and we add 1, then we get, I'm going to put it like this, and we add 1, then we should get Miracle's age. If we take her imaginary friend and we add 1, then we get to Miracle's age. I'm going to throw something in here also, though. If we take Miracle's age, Miracle's age is equal to the imaginary friend's age plus 1. So I want you to write 2 equations here. This first one and the second one. Let's go ahead and interpret one of the ordered pairs. So if imaginary friend is 3 years old, then Miracle is 4 years old. I'm going to write that a tiny bit. Okay, now you could have used the 2, 3, the 1, 2, the 4, the 4, 5, the 0, 1. You could have used like 100, 101. Like if we could put 100 here. Like you could have done any here that makes sense. Now finally, we are going to write this equation out. So imaginary friend plus 1 should give us Miracle's age. So I am going to take an imaginary friend. It can be any of these. I'm going to choose the 4. And then plus 1 should give me Miracle's age. Miracle's age when her friend is 4 should be 5. And sure enough, 4 plus 1 is in fact 5. I know this is a lot for like your first lesson in this, but I know you can do it and you'll be better for it. So let's look at the next example. So the amount of money in Keontae's pocket will be $3 greater than in Nene's pocket. So we're really talking about Keontae's money. Keontae. So we're talking about Keontae's money. So we'll put the money that Keontae has. And we compare that to the money in a Nene's pocket. So this is the money for a Nene. Oh, I should probably not put that in the same color. That was the whole point. So this is the money for Nene's pocket. So remember that we put them in the same order. So the one as before, if we cared about Miracle's age, she goes second. We cared about Keontae's money, his money goes second. And then we put this in regular order. So A, I'll put this in a different color than K. So Keontae will have 3 more. Okay, so I'm just gonna put some values here. Okay, I just put some random numbers there, right? And that means Keontae will always have $3 more. So if a Nene has 0, Keontae has 3. If a Nene has 1, then Keontae has $4. If a Nene has $2, then Keontae has $5. If a Nene has $4, Keontae has $7. And finally, if a Nene has $7, Keontae should have $10. Now remember, we put the ones that we're talking about, like we're talking about Keontae's money, really. That goes right here. So Keontae's money. And we'll put Anene's money down here. So if Anene has 0, then we got to count the 0, 1, 2, 3, 1, 2, 3. So if Anene has 0, then Keontae has 3. If Anene has 1, then Keontae has 4. 1, 2, 3, 4. If Anene has 2, then Keontae has $5. 1, 2, 3, 4, 5. And we can see that there's a pattern. We could graph the rest of these, but I can see that all we're doing is this, really. So I'm gonna try to sketch this. Okay. Now let's go ahead and write our ordered pairs. Anene would go first, and then Keontae, Anene's money would go first. Keontae's money would go second, because that's the subject of our problem, really, our situation. And for example, if we put $4 for Anene, Keontae would have $7. Let's go ahead and write our 2 equations. So if we take Anene's money, Anene's money, and Keontae has $3 more, so when we add 3 like that, we should get Keontae's money. So it would be Anene's money plus $3 will give me Keontae's money. We can also say that Keontae's money is equal to Anene's money plus 3. I want you to write both. Let's go ahead and interpret one of our ordered pairs. So let's just do this one since it's here. 4, 7. So if Anene has $4, then Keontae has $7. 4 and 7. 4, 7. Now let's go ahead and use one of our equations. Doesn't matter which one. I'm going to use the first one again. So Anene, his money plus $3 should give me Keontae's money. Anene's money, I'm just going to take this 4 again, is $4. Oh, then Keontae's money should be 7. So 4 plus 3 is 7. Yep, and that's what we were supposed to get. This is correct. That is it. Thank you.